Well, good afternoon, everyone. This is Audrey Russo on a September 9th, I believe today is. The dates all blur. I am very thrilled once again to have another business as usual, which is our daily interactive call. And with guests who, I personally have a great relationship with, and I'm very excited to hear them talk about their company, and that's Near Earth Autonomy. And I will introduce our guests in just a moment. Before we get started, I just want to get some housekeeping out of the way. First of all, we've put everyone on mute. We put you on mute because that's one of the ways that we can control the noise and anything else that's in the background and be considerate of our guests. But we also have a chat, and the chat is really used so that you can have a conversation with our guests. I try to get to almost every question, and we spend about 30 minutes essentially with our guests so that we can pack in the amount of information that they have to share, and so that you can enjoy your lunch. I do want to give a thank you to Huntington Bank. Huntington Bank has been with us right from the beginning of business as usual, as well as many other things we do in media and marketing. They have been very, very active in the small business community, particularly as the pandemic set in. They have been leaders, really trying to make sure that people get connected in terms of any kind of support during the pandemic period. But think of them when you think of any of your banking needs, because they've got lots of services. So I have an opportunity to jump in. I also want to give a shout out to Jonathan Kirsting. He is on our team at the Tech Council, and he is Vice President of all things media. And I do want to tell everyone that he just hit a milestone with us at the Tech Council, and he has spent 23 years with us at the Tech Council. So pretty impressive. And the Tech Council has been around going on 38 years. So he has been there for a significant portion of the transformation. So you can give him a shout out. You can send him gifts if you'd like.
I like gifts. I like that.
You can do that. So thank you, Jonathan, for all the work that you continue to do for all of us. It's pretty amazing.
Thank you.
And so now I'm going to jump in. I want to welcome the Chief Executive Officer and the Chief Operating Officer of Near Earth Autonomy. You saw we put their pictures up. They look a little different right now than the pictures that they put up, but they still are good looking. And they are doing some pretty incredible work right here in our backyard in the East End, and coming out of Carnegie Mellon. I am not going to hijack the story. I'm going to let you listen to them, and they are going to introduce themselves. And so quickly, I want to set the table, and I want to introduce, we have two people here today, and it's Sanjiv Singh and Marcel Bergerman. And I am going to start with Sanjiv and welcome him to the show. And just tell us a little bit about Sanjiv so that we can sort of understand Sanjiv, the man, and the journey that you've been on here in Pittsburgh. So welcome, Sanjiv.
Thank you so much, Audrey. So as a brief introduction, I arrived at Carnegie Mellon in 1985 to work on some of the early ground robotics. I got my PhD there, and then I've been on the faculty since 1995. And a few years ago, we, along with a few people, Marcel, Lyle Chamberlain, Sebastian Scher, and we started Near Earth Autonomy. And now we're a company here in Point Breeze, about 85 strong. And we focus on autonomy for air vehicles.
Great. So great. Thank you. Is this your first company, Sanjiv?
No, actually, it's number 3 of 4.
Okay. So you are experienced and you have quite a commitment to Pittsburgh. So thank you for that. I want to jump now to Marcel. Welcome, Marcel. You serve as COO and you're also one of the co-founders. Thank you for joining us today, and tell us a little bit about yourself.
Thank you very much, Audrey, and all the PTC friends. I'm probably the only Brazilian who has moved to Pittsburgh twice, once to pursue grad school and once to work at Carnegie Mellon, and eventually to co-found Near Earth Autonomy. Here at Near Earth, I like to think of the role of the COO much like the role of the PCP, who takes care of a person. PCP meaning taking care of people, contracts, and projects, ensuring that we are attracting and retaining the best talent making sure that all of our contracts, they run to the benefit of the company's vision and strategy, and ensuring that all of our projects are running, the trains are running on time and on schedule.
So it's a good job to have. It's busy, and you're working on a precise timeline. So thank you, Marcel. I'm going to jump back now to Sanjiv, and we're going to toggle a little bit back and forth, but I think you'll appreciate the kind of perspective that they bring to the subject matter. So Sanjiv, describe sort of the origin and premise of Near Earth Autonomy.
Yeah, so when I arrived at Carnegie Mellon in the late 80s, we were working on outdoor robots, and the idea was this is about robotics in environments at large scale, in conditions that you could not control, as opposed to being inside a factory or where you can't actually control the ambient conditions, where you mostly see robotics. So this was the very start of what we now call field robotics as a discipline. And I was there right at the very exciting genesis of that area, working on some of the earliest ground vehicles that started to move around. And over time, the field got more specialized, and we saw an opportunity in using some of the same technologies for air vehicles. So basically what we wanted to do was do in the air, use a third dimension, with the same kinds of ideas to be able to fly air vehicles to go from A to B, stay safe, be efficient, that kind of thing. So we were developing some of the same technology, and over time that got some traction of its own, and we were presented with some great opportunities that led to the start of this company.
So in terms of that, what kinds of problems were you specifically hoping to solve? Did you have any premise there about what specific problems?
Yeah, so, generally speaking, we think about two broad problems of many, many things that you might want to do with robots. One of them has to do with scouting, which is getting some information back to somebody who cares about it. Putting a camera or some sensor far from the person who wants to deploy it. So that you think about that as scouting. You might think about that as something like reaching underneath a bridge to get some data, or flying very far away to be able to check that place out, going inside a nuclear power plant where there's been a disaster, that kind of thing. And then there's another whole class of applications which is about transport, which is moving people and goods from one place to another. So you see this exact same thing happening in ground vehicles, where scouting applications where robots are used to get information, and another whole class of things which has to do with actually transporting people or goods. Okay, so hence all of the self-driving cars that you're seeing being developed there. So if you put up the slide that I sent, I'll talk to you a little bit more specifically about what that means in the transport sector. So this is something we call our ecosystem, and it's really actually some very simple way of thinking about what autonomy really comes down to for commercial transport applications. So we start with before the flight is actually takes off. So you have whatever the aircraft is, you have to do some planning with any known information about the world or weather or no-fly zones that you might know about, and then plan some missions, including how to avoid any other aircraft that might be flying in that area. Then we want to be able to stay safe, and that means avoiding obstacles, static objects, and avoiding collisions with other aircraft. Very big thing for aircraft is that because a lot of them use GPS to stay stable, we want to be able to fly even if GPS is degraded or somehow or the other jammed or unavailable. So we have that capability to be able to fly safely. A big difference between flying vehicles and driving vehicles is that it's not so easy to sort of like pull over, so to speak, right? You want to be able to, if something happens, maybe there's a malfunctioning component on board, maybe there's a fire, some sort of sensor may have gone out, you have to land very quickly. So that is what we call contingency management, figuring out what to do in an emergency and then taking this evasive action or some sort of safe action to be able to deal with it. Then we think about landing precisely. You can want to be able to indicate to a vehicle that's flying, okay, this is the place you want to land. And if you have some infrastructure you can deploy, then that can be used to tell the vehicle where to land, say maybe at something like a heliport, or even in the field somewhere where you want to be able to take this. And then finally, the idea is that if you take a pilot out of one of these vehicles and it's flying by itself, either carrying passengers or goods, it has to be able to land safely. And so as a pilot would check the place that the aircraft is flying to, we want the system to be able to do that. So these are some sort of technologies or use cases that come together as what we think of as autonomy. And there are other sort of cases that are somewhat more rare, but I think this sort of gives you the idea of what a future commercial autonomy ecosystem might look like.
No, I think it's great. I think it really does a nice job of breaking down all the different pieces of the workflow, and that very often people just don't understand each segment of it. They think of autonomy, particularly for those of us that aren't working inside of companies, we think of autonomy as just sort of the end game, right? And you've delineated for us all the different pieces that will make something successful. And so I appreciate that. No, I appreciate that. And I hope that helps our audience, particularly for those who are not in this space and working in this space and want to understand you. So thank you for that. And well, this is recorded, so people will have a chance to reference back to that and understand, you know, your intentions. So if I go back to Marcel real quick, you have 85 strong people that are actually, you know, with the company right now. What essentially are the skill sets? What's the majority of the skill sets, or could you cluster them in terms of the skill sets of the people that work for your team?
Absolutely. And by the way, it's going to be 87 people as of September 21st. We are really excited that we got 2 job offers accepted this week, and we are making 1 more tomorrow. The company has hired 14 people, well, 16 including these 2 since January, and 14 since March 1st, since the pandemic started. So we are very fortunate to be in a position where we can continue growing the company. It's a great group of passionate, perseverant people who truly believe in this ecosystem that we are showing here and the potential for autonomous flight to revolutionize what we call mobility and inspection, right? Transporting goods and people and bring information about the world to the people who need that information. We started, as you would imagine, as a core robotics company. The first, I don't know, maybe 10, 12 people were mostly robotics folks, right? But then as the company grew, of course, we incorporated the other engineering and technical disciplines that would make for the need to put real products out there, real systems that will solve real problems in mobility and inspection. Right, so while we still have a core of robotics engineers, we have a strong group of electrical, mechanical, software engineers, system engineers, a growing user experience and user interface group. Not to mention, and very importantly, we have a dedicated group of people for flight operations led by 2 retired Army helicopter pilots. So we have a group of people, depending on how you count, 12 people who are singly dedicated to flight operations and integrating our technologies with other people's aircraft. So imagine in a company of 85, 87 people, 12 are dedicated to safe flight and integrating technology with other people's aircraft. Not to mention, of course, our project managers and IT and financials, HR, and the entire support we have from our administrative folks. So it's a blessing. It's a great group of people, again, passionate, perseverant, and who truly believe in what the company is doing.
Yeah, it's amazing. It's been a thrill to watch from afar. So thank you for that. So Sanjiv, a few weeks ago, you announced you were partnering with Kaman Aerospace to develop the system initially designed for KMAX, the KMAX helicopter. which actually can carry 6,000 pounds or 6,000 pounds of payload. What are the real world implications of this, and how does that fit into your overall strategy and vision?
Yeah, great question, Audrey. There are two kinds of things that I think we could think about. There's solutions or problems of today that I think we can tackle. When you have a helicopter of that scale, then you can actually transport a lot. One application that is on everybody's minds these days is firefighting. And it actually turns out that the K-MAX is very suited to be used in firefighting applications. So it is able to carry a very large load through a sling, and as you would with some sort of retardant or water, and to be able to precisely deliver it onto a fire. Now, one of the things that happens, we don't do this today, and our project's not targeted towards that specifically, but the idea is that an unmanned K-MAX would allow this kind of a vehicle to fly in applications where it's very dangerous for people to go. You may have read about the recent fires and helicopter rescues that happened just recently in California. And the pilots report that there's very, very difficult, probably the hardest flying that they've ever done, because the visibility is close to zero and they have to line very precisely. So you can imagine that hazard has always been a justification, and this is something that we could tackle in the near future with a vehicle like that. This is an existing vehicle that was built for logging applications, to be able to pull large logs out of forests where there are no roads, and it's also used in construction of highways and bringing pylons to these places where they're placed very delicately. So I think a near-term application in disaster recovery, humanitarian relief, that kind of thing, any kind of rescue, search and rescue is another big application here. Now, that is specific to that configuration of an aircraft, but actually there's a very large number of applications, I think, that are in the future, very exciting, which have to do with point-to-point travel. And there's a new class of aircraft that some of you may know of, which is they're called eVTOL. They stand for Electric Vertical Takeoff and Landings. And now these are interesting aircraft because they could be much cheaper and much more reliable. They have the potential anyway, they're not there today, but they have the potential of being much cheaper and much more reliable than the helicopters we see today, which are sort of require very skilled pilots and a lot of maintenance just because of the way they're built. So the electric VTOL aircraft of the future promise something that we've been thinking about for a long time. We've been thinking about this sort of Jetsons age where you could fly from point to point. Now, I'm not sure that equates to something that goes into your garage and then you fly to your barbecue on the other end of the city, but I think there is this potential of doing point-to-point transportation, which electric VTOL could really help with. And so the technology we're developing here for the K-MAX, although there are great applications today, actually is even more significant if you think about the future of transportation in this electric VTOL that is coming. Now, how soon all of that can come together is a question we can talk about, but I think that this partnership gives us the ability to start thinking about working at that scale, but with very reliable and capable aircraft.
Yeah, I mean, I'm excited because my mind goes, really far out. I'm saying, oh my gosh, look into the future. What are we going to imagine? The world on demand. What does that look like in terms of everyday life? You've given, the example of, the Jetsons and, having it in your garage and, going. But I think there's like a lot of those kinds of examples. Wouldn't you agree, Marcel? Like aren't there a lot of examples that we can imagine that actually has always made me excited about the work that your company has done? So you talk about safety, the firefighting, the changes in our global climate, the thought of that. But there are so many other fun things that I can imagine will make the world on demand.
Yes, absolutely. And look, while it would be great, I've been saying here at the company that I'd like to eventually retire. And by the way, the saying is that when I retire, I'm going to get a 9-to-5 job. But on top of that, hopefully go to a vacation with my family somewhere. And I'd like to see the drone bring me a beer, right? And while that's just kind of like a fun way to imagine the future, here are a few more practical aspects of that we are working very seriously towards. So one is, for example, military logistics, right? So imagine if we could have our Army and Marines deploying, rather than how they do today in very large convoys where they have to carry everything they need for every mission and being subject to IEDs and other dangers, if they could deploy in very small, nimble, almost inconspicuous platoons, and then have their supplies being brought to them on demand basis by air vehicles, bringing the supplies that they need, that they can almost literally order on a mobile device, right? So they go out in small groups, and no matter where they are, they summon the supplies, and they come in the middle of the night flying. They are delivered, and out people go to their next mission. Imagine if you could deploy 300 or 500 of these medium and small and medium-sized drones to hundreds of different locations in a region affected by a hurricane or an earthquake. Before the waters recede, before ground support and rescue can come in, and even before large helicopters can even reach and land in those places to rescue people, imagine you could send hundreds of flying vehicles with water, food, medicine, and they would be intelligent enough to be able to fly safely, avoid obstacles along the way, get to their destination, see with their own eyes, if you will, with their own sensors, where are the downed trees and the destroyed houses, and find a small but dry, flat patch of land to land, sound a horn, and people come and get supplies they need to survive another 24, 48 hours. The day we can do that, it's the day that we will have succeeded in the vision of Near Earth Autonomy.
And the day that you achieve that is the day that I'm going to be your salesperson. Just for the record. So
you've already been a fantastic salesperson for us, Audrey, bringing us contacts and people to hire, and we're very, very appreciative of that.
Well, listen, Alex Fossil said, in your case, Marcel, it would be a caipirinha. It would not be a beer. So just
we'll surely do that, and I hope we can do that together.
and then Rebecca's asking, how far and long can these autonomous aircrafts actually fly? So they're just talking just tactically in terms of a distance for where we are.
Yeah, so, a lot of that has to do with the kind of vehicle that we're talking about. I mean, this is really some attribute of the physical vehicle. I think what we're seeing is that the current electric VTOL vehicles can fly about 20 minutes, but that is really a limitation of battery energy density, not some sort of other limitation here. If you have a more standard kind of a helicopter like we're using, well, then, it really is actually a question of how much fuel can you carry. In some cases, what they've done is they've taken the cabin of the vehicle and added fuel tanks there because, you don't need a person on board. So these things could fly many hours at a time. There's no real limitation to how far they could fly.
Mm-hmm.
And if I could complement that, Rebecca, it's an important question for the following point of view. Our work is about developing the autonomy or the intelligence, if you will, the eyes and the brains that go on aircraft. We make a big effort at producing autonomy systems that are aircraft agnostic, that can be integrated with a multitude of aircraft. We are not an aircraft manufacturing company. We are an autonomous systems company. So we partner with a number of companies out there who provide small, medium, large size aircraft, both rotary wing and fixed wing in some cases. And we give that aircraft intelligence, if you will, to be able to execute missions autonomously, right? So that is a very important part of our pitch.
Part of your plan. So no one knows how long this is going to take. I'm getting very impatient. So I really want to understand what does it mean? Like what are the inhibitors, right? Or what are the opportunities?
Right. So, what we're seeing right now is this technology is feasible, right? We can do this, certainly can. That wasn't actually very clear to get on, and I think we're being able to convince people that the technology is feasible. From our point of view, for this technology to become commonplace, for it to be adopted such that you see this happening, like, you would be able to use it or you'd see it around you. I think there are three things that need to happen. One is the technology needs to be capable, broadly capable. It needs to be reliable, and it needs to be affordable, okay? And all three of those things have to happen for it to become commonplace in the way that we think about, automobiles today. If you find some use case where you can take one of those out, maybe it doesn't have to be affordable to the point that, the public can use it, but other agencies like relief agencies, disaster recovery people, or the military can use it, then we can get one step closer because we don't have to solve all three of those problems all at once. I think this is important. And this is about adoption of any advanced technology, I think. And so that's what we have to be continuously doing, is showing the capability, the reliability, and the affordability. And that's hard to gauge as to when it is, especially because as a society, we haven't figured out where that reliability number has to be, right? We haven't figured out, even for our self-driving cars, what is an acceptable accident rate, et cetera. One way to do that is to compare against what happens today, not like, accidents per 1,000 for just for autonomous vehicles, or some other numbers that the people in the aviation world use. So I think that would be some way of thinking about how many lives are we saving when we use some technology, rather than like how many people get hurt, or what is the damage to the environment, for example, when you do have a mishap. So that conversation is happening at the same time as we're showing the capability and the affordability. And I think when we have a good use case, then it will become, I think you'll see these things, there will be some compelling first users or some use case where people will say, yes, we can take a risk for this, and that will spur these things on.
So Jonathan, you want to wrap up with a couple of the questions I think you have?
Absolutely, yeah. So a great one here from Cheyenne is, at some point, this sounds like this is basically going to be an autopilot for an airplane. And I'm assuming, I know at least pre-COVID, I kept hearing a lot of shortages of pilots for certain situations. So it seems like this could fill those gaps, huh?
Yeah, I mean, there's different kinds of pilots, right? I mean, we'll see how the aviation industry sorts out as a whole. But what happens is that what you want for these kinds of aircraft is you need helicopter pilots. And yeah, I think the idea is these people who are used to going up and down, I think we'll see how this sorts out. One idea is that the effect of the pandemic might be that we see less hub and spoke kind of travel and more point-to-point travel. And certainly this kind of technology can help with point-to-point travel. And that is very difficult to do right now. And there is certainly a shortage of those kinds of people.
Well, we are wrapping up our time with you. I want to be sensitive to everyone. They know that we spend just about 30 to 35 minutes here. For me to say that I'm proud of the work that you're doing, I do nothing other than just try to be your cheerleader and make connections and shine the light on you. But this is just another example of the kinds of incredible people and leaders who are building tomorrow right here in Pittsburgh, growing, stable, committed, and relentless in their pursuit. So look up Near Earth Autonomy. You can find you know, a lot more information out there. This is recorded, so obviously if you want to revert back and look at the slide that Sanjiv put out there, that might be helpful. Happy to do that. I want to thank Marcel and I want to thank Sanjiv for just being good technology stewards for the work right here in Pittsburgh, because you actually could have done that anywhere else. You actually could have.
Thank you, Audrey, as well. You know, I don't know how many members the PTC has. I imagine it's many, many hundreds. But every time that we talk and we talk to anyone in the PTC, it feels like we are the only member company. You guys give us a lot of attention and caring and love, and we really appreciate that. It's a pleasure to, and it's an honor to be a member of the PTC.
Thank you so much. Thank you. Sanjiv, until we see you again, thank you, everyone. Stay tuned. We're back tomorrow. Jonathan, who do we have tomorrow?
Tomorrow we have Grow with Google stopping by in Bridgeway Capital. So if you have a small business, you're looking to amp it up, you got to tune in because there's some great resources out there for you, just ready to help. So tune in.
So thank you, everyone. Stay tuned. We'll have a great day. Stay safe, and we'll see you tomorrow.
Thank you, Audrey.
Goodbye.